When writing proofs, remember that every proof will begin with the given statements. So we're going to begin here with AB is congruent to DC, and angle BAC is congruent to angle DCA. Then I'll go to the picture and I'll place the markings that represent these given statements. So AB gets a line through it and DC gets a line through it since they are congruent. Then we're going to mark angle BAC, which is right here with one arc, angle DCA with one arc. And so now I got to figure out what else can I add to the proof. I have already written down, use the stuff that they have given me. So now I look at the triangles and decide where do they touch. Well, they're touching here along the side AC. So that's the missing statement. AC is congruent to AC. That's the reflexive property. And then when we want to say that two triangles are congruent, we have to go to our shortcut. So reminder, the proof will end with whatever it is that they wanted me to prove. And then I look at one of the triangles to decide what this shortcut is. So this shortcut is side, angle, side. For 26, writing down the givens. And then I'm going to mark those things in the picture. So the first given, angle E, is congruent to angle G. And then the second statement doesn't have a congruent symbol in it, so I can't mark anything just yet. But I would say that if F is the midpoint of the segment, then it cuts the segment into two congruent parts, and I can then add the markings here. So those markings now tell me that EF is congruent to GF. And then remember, we follow up a given statement that doesn't have a congruent symbol with definition of whatever that term was. So definition in this case of midpoint. So now as I look at this, I still have a missing congruent statement. When I look at the triangles, again, they touch, but now they touch on these angles. So now I can say that these two angles would be congruent, and that's because they are vertical angles. So those two angles I'm going to write as angle EFD is congruent to angle GFH, and then that's because they are vertical angles. You might also use VAT for vertical angle theorem. Now I'm almost done, so I can tell that this proof is going to end on whatever they asked me to prove. So I knew that ahead of time. So I'm asked to prove that these two parts are congruent. Well, we show that parts are congruent by CPCTC, which would mean that the missing statement is that the two triangles are congruent. So these two triangles will be congruent by, so looking at just one of the triangles, I have angle, side, angle. 27, we'll see if we can get through this one a little bit faster. So if I fill this out kind of out of order, but at least with what I know we have angle F is congruent to angle E. We have DE is parallel to GF. I will end with DE is congruent to GF, and again, these are parts, so I can say it will end on CPCTC, and the step right above it is going to be that the two triangles are congruent by one of the shortcuts. So for the reasons here, there's the givens. Mark those angles in the picture. So F gets an arc and E gets an arc. Then we have DE is parallel to GF. Whenever you're given that you have things that are parallel, you should start hunting for alternate interior angles or corresponding angles depending on the picture. So for us, we have alternate interior angles. So where I just highlighted the Z shape here, top and bottom are the parallel lines. The diagonal would be like the transversal, and here would be the location of the congruent alternate interior angles. So now I can say that angle EDG is congruent to angle FGD, and then that's going to be alternate interior angles. So still missing my third statement, so I look at, well, where did they touch? They touch on this side right here, and so I can say that DG is congruent to DG by the reflexive property. And then that's enough now to say that the two triangles are congruent by angle, angle, side.